open. Note, B is higher than A, and B is in the denominator, right? So this is going to be actually smaller. There's going to be a negative number. Negative number. Right? Cool? So the door going to go in that direction. Finally, okay? Is that clear? Good. So just a comment about it is that if the magnetic field was uniform, so these two also would cancel each other up, okay? So if you have a closed wire in a constant magnetic field, and this is classic for the exam, you know, to give you a really hard shape and say it's a closed loop, right? And the magnetic field is constant, the force it's going to experience is going to be zero. It's going to cancel each up, okay? Each dl would see another dl with the other sign of the force, right? So they're going to cancel out. So good, guys. Next week, what's it going to do? Remember that we learned about Coulomb's and we learned about Gauss, two methods to find the electric field. Right now, I need to teach you a new method to find magnetic fields. So this is going to be the concept of next week. Okay? Okay, guys? So, and it's going to be easier than what we had experienced in electric field. Guys, see you next time. Good luck. Okay. Can you repeat the last thing you said about it being zero? Yes. Yes. So if you're gonna have, I'm just gonna do it like a stick. Okay. So you ask me what's gonna happen. What is the last thing that I talked about? So the last thing that I talked about was that if we have a uniform magnetic field, let's say in this direction, but it's uniform, all space is uniform, and we have some closed frame, it could be this shape, I don't care. Each dl gonna experience some force, but the other one in the other direction gonna experience the same force in the other direction because the current is in that direction, and here is that direction. So the force is gonna end up with different signs. So they're gonna cancel each other up, eat each other up. So if it's a closed, if it's a closed loop, it's gonna be zero sign. Okay. So for the force.
Why was this one not?
Because the magnetic field in our case was not uniform, right? It was changing depending on the x value. Perfect. See you next time.